To find the vector determined by the coordinate vector and basis, we just recognize that the components of the coordinate vector are the coefficients of the, when we write x as a linear combination according to the basis elements. So remember that if we have x equal to our coefficients times the basis elements, then this just means that our x is equal to, our first weight is 5 times the first vector in the basis plus 3 times our second element in the basis. And we get that x is equal to 5 times 3 minus 3 times 4. So that's going to be 15 minus 12, or 3. And then negative 25 plus 18. To find the coordinate vector of the given vector x relative to the basis, we just set up what's going on. We know that if x is equal to c1 times b1 plus c2 times b2, then we have 2, 1 equal to c1, which is an unknown value, times 1, negative 3, plus c2, which is also unknown, times 2, negative 5. And that is, so c1, c2 would be our coordinate vector. And what we get from this is that c1 plus 2c2 is equal to 2, and minus 3c1 minus 5c2 is equal to 1. And so it's just a system of two equations and two variables. I can solve it very quickly using substitution, and we get c1 is equal to 2 minus 2c2, and so let's just plug that into our other equation, and we get minus 3 times 2 minus 2c2 minus 5c2 equals 1, which gives minus 6 plus 6c2 minus 5c2 equals 1. And so that's c2 equals 7. And then plugging that in, we get c1 equals 2 minus 14 or negative 12. And so our coordinate vector is coordinate vector of x with respect to b would be c1 equals negative 12, and then c2 equals 7.